Welcome to a new video lecture. Today we will discuss a very new concept related with influence line diagram. When a train of continental loads traveling across a beam, then what is the condition for shear force at a point in the beam? Okay, so with the help of a diagram we will explain. A simply supported beam with the supports, let it be A and B, and a train of continental load is traveling from this point A to this point B. Then at a point in this beam, let us assume the point BC, what is the maximum shear force or what is the condition for maximum shear force occurring at the point C? Then what do you mean by train of continental loads? A series of loads is passing over a beam, that is called a train of continental loads. Let us take the situation of a truck is crossing a bridge. Let us assume this is a truck. It is passing over a bridge. Then each axial points will act as the continental loads. Depends upon the number of tires, the weight will be varying. So let us consider the weight be W1, W2 and W3. The distance or the gap between this W1 and W2 be A and between W2 and W3 be B. Okay. And the distance from this point, support A to the point C is Z, and the total span of the beam is capital L. So, if a unit load is traveling, we can find out easily, we can draw the diagram of IL, the influence line diagram for a unit load in this format. Or if a series of loads is acting, the load's value will have different ordinates, the point, and we can multiply this ordinate with respect to that load. If here W3 is acting, W3 multiplied by, let us assume this ordinate be Y3. So W3 multiplied by Y3. Likewise, we can easily find out the shear force. So this is the situation if all this continental loads are acting to the left side or behind the C, it will have the maximum negative shear force. We already discussed. And if all the continental loads in front of the point C, that means all the loads W3 is acting at the point C, it will give the maximum shear force. So there are some situations, if W2 is acting over the point C, let us consider that situation. If W2 is acting at the point C, then sometimes this is the situation. This W2 will be giving the maximum shear force. So what is the condition for that? Either you can use trial and error method. Always, if number of loads are there, 5 or 6 loads are acting seriously, you have to find out this. After placing W2, then you have to place W3. Likewise, you have to find out. That is one of the method. Okay, while doing problem, you will get more clarity. So here I am deriving an expression for how to easily calculate the value. So let us go to the derivation. So if W1 is acting at the point C, and we can find out that total load, this W3 plus W2 plus W1 will be, let us consider capital W. Okay, and it is acting at a distance x from the support A. So the remaining distance will be L minus x. So we can easily find out the reaction at B will be the capital W, the total load multiplied by the distance x divided by L. Or you can use reaction RA plus RB equals W, then sigma MA equal to 0 or sigma MB equal to 0. Then you can find out the value of RB, value like Wx by L. Then after a point of time, this W1 crosses the point C with a distance A, then the capital W from this point also move a distance A. Okay. So the reaction at B will be changes to W multiplied by X plus A by L. Okay. Or you can use the same equation RA plus RB equal to W, but the distance will change. X plus A will come here. Okay. Then what is going to happen? That change in shear force at the point C depends upon two values, that is change in RB and also W1. Okay, here the value of RB is W multiplied by X plus A by L, but the original value is W X by L. So if you take the change in reaction at B, the value is going to be minus W A by L. If you take, this is the original value, and after this load transfers, the value is going to be W multiplied by X plus A by L. And also it depends upon the W1 also. So according to the sign convention, we will follow this minus W A by L. Already we get the change in reaction at B. And here the W1 is positive since we are using this sign convention. Vx is acting here, the W1 is acting downwards, so the positive sign will comes here. So this is the condition for finding out which load will act as give the maximum shear force condition. And also, if the value in this point, change in shear force, it gives negative value, it means that the increase in shear force. Okay, and if the value in the change in shear force gives positive value, you should not consider that load. If when this W is acting at the point and you get a positive value, then you can ignore the situation. Okay, so this is the condition for finding out the maximum shear force at the point C when a constant load is acting over the B. Okay, while doing problems, it will be very clear. Either you can use trial and error method, or you can use this condition for finding out the maximum shear force at the point in the B. Okay, so with this we'll wind up today's section. Thank you all.